Hello everyone and welcome to section 4.1 where we're talking about system of linear equations and solving them by graphing, substitution, or elimination or elimination. Okay, so first of all, what is a system of linear equations? It's just two or more equations, linear equations grouped together. Okay, so when they meet, that's considered a solution. So the solution is the solutions are values of the variable. So in other words, ordered pairs that make both equation or more, if there are more, equations true. Okay, so let's say, for example, here we have a system of equations. We have x minus y is equal to -1, and we have 2x minus y is equal to -5. To tell if an ordered pair is a solution, we just plug that in. So you would do -2 minus -1, and is that equal to -1? So we have -2 plus 1. Is that equal to -1? And yes, it is. -1 does equal that. So then we say, yes, it's a solution. So what about B? So that's a solution for the first one, but we need to also do the second one, sorry. So 2 times -2 minus, and then y is -1. Is that equal to -5? So then 2 times -2 is -4. Minus a -1 becomes plus 1. Oh, actually, this is not equal to -5. Oh, interesting. So since they do not equal each other, it's not a solution. Sorry about that. So this is a no. No. Okay, so it was a solution. So notice, so what did we do? It was a solution to one of the equations, but not the other. And in order for it to be a solution of the entire system, it has to fulfill both, okay? So let's try B. Here we have x, y. So -4 minus -3. Does that equal -1? Question mark, -4 plus 3. And that does equal -1. So that one checks. But now we need to check equation 2. So 2 times -4 minus -3. Does that equal -5? Question mark. -8 here. These two become a plus 3, -5. And it does. -5 does equal -5. So then, yes, the second one is a solution to the system, okay? So let's look at what are the possible relationships between two lines, okay? So either one, you have two separate lines that have different slopes, different y-intercepts, and or maybe it's the same, but they have different slopes. They're going to intersect in one point, okay? Parallel lines, you have the same slope, okay, and they never cross, and different intercepts. Now, this will have no solution because they never cross. So the third one, you have the same slope, and you have the same y-intercept, because it's actually the same line. So this one is infinitely many solutions. And then this one is only one solution. Okay, so how do we solve by graphing? We graph both equations, tell whether they're parallel, intersecting, or they're the same, and then we identify the solution. So let's say here we have 2x plus y is equal to 7. X minus 2y is equal to 6. So equation 1, I'm going to write that in y equal mx plus b form. So minus 2x minus 2x. So then I get y is equal to -2x plus 7. So here the slope is -2. And the y-intercept is 7. Okay. And then the second one, I'm going to do the same thing. X minus 2y is equal to 6. So I'm just going to solve it in y equal mx plus b form. 2y is equal to -x plus 6. Divide by -2. Y is equal to 1/2 x minus 3. So then in this case, the slope is 1/2. And then the y-intercept is -3. Okay. So if I was to graph these, you should see. So we have here, I'll do the first one in, I guess, pink. Let me draw the little tick marks. Okay. Okay, sorry about that. And then, okay. All right, so we start at, so the first one, we're starting with b is equal to 7, so that's our starting point. 1, 2, 3, 4, 5, 6, 7. Okay, and then since the slope is 2, negative 2, we go down 2 and to the right 1, down 2 and to the right 1, down 2 and to the right 1, down 2 and to the right 1. Okay, so this is it. This is the line right here. I did so many, but you know, a little extra. We went a little extra. This is y equal negative 2x plus 7. Let's do another one in another color. How about blue? Sure, why not? Okay, so blue, we have here y is equal to 1/2 x minus 3. So the y-intercept is negative 3. So 1, 2, 3 here. That's the y-intercept, my starting point. My slope is 1 over 2, so I go up 1 over 2 dot. Up 1 over 2 dot. Up 1 over 2 dot. Okay? So we can actually tell where they cross. They cross here at negative 1. Let's see here. Let me pick another color. They cross here at this point, okay, which is 1, 2, 3, 4 for x, and y is negative 1. Okay. Yep. So this is the solution, and you can plug that in and check, but yep, this is the right solution. Okay, so that's graphing. Again, what else a couple of things we want to say about the types of solutions. Again, if they intersect, you have one solution, and we call that a consistent system. And we also say that they are independent, parallel, no solution, inconsistent system, and dependent. And if it's the same, you have infinitely many solutions because they cross infinitely many times. It's considered a consistent system, and they are dependent. All right, so how can we tell if they're what the number of solutions are and then what type of equations they are? So we can put them into y equal mx plus b form and compare the slopes. Okay, so for A, we already have y equal 3x minus 1. So let's go ahead and simplify the second equation. So I'm moving everything over, minus 6x minus 6x. Negative 2y is equal to negative 6x plus 12. Divide both sides by negative 2. And we get y is equal to 3x minus 6. Okay, so right away, notice that they have the same slope. Okay, but they have different y-intercepts, so these are parallel lines. So lines are parallel, right? They're parallel, so it's consistent, but it's inconsistent system, sorry. They do not have any solution, so no solutions. No solution, inconsistent system. Consistent. Okay. Okay, what about for B? We have 2x plus y is equal to negative 3. So I'm going to go ahead and put that into y equal mx plus b form. Minus 2x minus 2x. Y is equal to negative 2x minus 3. So that's for the first one. Now the second equation, we have x minus 5y is equal to 5 minus x. We get negative 5y is equal to negative x plus 5. Let's divide both sides by negative 5. We get y is equal to positive 1/5 x minus 1, because 5 divided by negative 5 is negative 1. Okay, so these have different slopes and different y-intercepts. So these will intersect, okay? They're going to intersect, and they're going to only cross at one solution. So one solution. Okay, and this is a consistent system. These are non-parallel lines that will eventually cross. Wait, did I just do that? I just deleted it for some reason. Okay, never mind. Here it is. Okay, yes, great. Okay, now let's talk about substitution. Substitution is basically when you take your two equations, one of them you solve for one variable in terms of the other, and then you plug all that whole into the second equation. The idea is that you get an equation that is only has one variable. Okay, so let me show you what I mean. So here we have 2x plus y is equal to 7, and we have x minus 2y is equal to 6. So for the first equation, I'm gonna solve for y, but I could have done it either way. So I'm gonna solve for y here. I get y is equal to 7 minus 2x, or you could say negative 2x plus 7, same thing. Now I'm gonna take this, right, this part here. So this y is equal to this. But the second equation has a y. So instead of y, I'm going to write 7 minus 2x. I'm going to substitute, this part here into this y. Why am I going to do that? Because they're equal. So that's fine. So substitution. So x minus 2 times, and now instead of y, I'm going to put 7 minus 2x equals 6. So notice that's what I did here. Okay, fine. So now we're going to solve for x. So x minus 14 plus 4x is equal to 6. Like terms, 5x minus 14 is equal to 6. Add 14 in both sides. 5x is equal to 20. Divide by 5, we get x is equal to 4. Okay, so now that we have x is equal to 4, we can solve for the y by using one of the other equations, okay? So I'm going to use y equals 7 minus 2x. So y is equal to 7 minus 2 times, and then here I have x is 4. Okay, so that's going to be 7 minus 8, negative 1. So y is equal to negative 1. So final answer, 4 comma negative 1. Okay. All right. The next thing we need to go over is elimination. So elimination, you write both the equations in standard form. Remember what standard form is? Ax plus by is equal to some constant. And then we decide on what, if there's fractions, we clear them. If they are whole numbers, basically the idea is that we're going to add the equations together, and in doing so, we're going to eliminate one of the variables by making them have the same coefficient but opposites. Okay, so going back to this problem here. So what does that mean? Okay, fine. So let me multiply the top equation by 2. So let's say my goal, I want to get rid of the y's first. I'm going to eliminate the y's. So if I multiply the top by 2, I get 4x plus 2y is equal to 7. And then underneath, I have x minus 2y is equal to 6. So notice, same coefficient but opposites, right? That's because now I'm going to combine these together, okay? If I do that, what's going to happen to the y's? They're going to be, wait for it, eliminated. Yes, so 5x is equal to, and here you have 7, wait a second. I messed up here. This is 14, right? Because we're multiplying everything, so this is 14. Sorry about that. 14 plus 6 is 20. 5 divided by 5, we get x is equal to 4. In order to solve for a y, we just plug it into either one. So I'll plug it into here. 2 times 4 plus y is equal to 7. So we get 8 plus y equals 7. Minus 8 minus 8. Y is equal to negative 1. So see, we get the same answer, and it's a lot nicer this way. Most of the time, elimination is better. Let's do another example of elimination. So here, let's say we don't know what coefficient to use, so we use the LCM. Pick two of them and then find the LCM and do that. So here I'm going to choose the y. I noticed that the 3 and the 2, the LCM is 6. So what I'm going to do, and they're already opposite signs, so I'm going to multiply the top by 2, and I'm going to multiply the bottom equation by 3. So let's go ahead and do that. So the first equation is now going to become 8x, because I'm multiplying 8x minus 6y is equal to 18. And then the bottom one is going to be 21x plus 6y is equal to negative 18. Okay. So then when I combine these together, what am I going to get? These will cancel. This is actually going to become 0 on the right side of the equation because 18 minus 18 is 0 today. And then here we're going to have 29x. But 0 divided by anything is still 0. So we get x is equal to 0. That's fine. So let's go ahead and solve for y. I'm going to plug it into the second equation. 7 times 0 plus 2 times y is equal to negative 6. This becomes 0. Then we just need to divide by 2. So y is equal to negative 3. So my answer is 0, negative 3. Okay. What if we have, dun, 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 fractions? We love fractions. So first thing, let's clear the fractions. I'm going to multiply this entire one by 2. And then here, since I have 2 and a 3, I'm going to multiply by the LCM, which is 6. Okay, our least common denominator. That's fine. Okay, so on the top, I get 2x plus y, because 1/2 times 2 is 1, is equal to 12. And on the bottom, I'm going to write it out because it's I want to make sure that you guys can see what I'm actually doing. I'm multiplying every single term, right, by 6. So 6 times 17 over 2. You don't have to write this out if you don't need to, but it's just good to see. So 2 goes into 6 3 times, so we get 3 times 3x, that's 9x, plus 3 goes into 6 twice, 2 times 2y is 4y, equal 2 goes into 6 3 times. 3 times 17 is 51 today. Okay, so we have that. So I still don't have, the same coefficient and opposite. So what I'm going to do now, I'm going to take the first one and I'm going to multiply that by negative 4 to get rid of the y's. Okay, so doing that, what am I going to get? I get here negative 8x minus 4y is equal to negative 48. Okay, so now I can go ahead and add these together. These cancel out, of course. 9 minus 8 is just 1x today. 51 minus 48 is 3. So great, look, we have x is equal to 3. So then let's plug it into here to solve for y. Well, technically, we're plugging it into here, right? And we're solving for y. So fine. So 2 times 3 plus y is equal to 12. So we get 6 plus y is equal to 12. Subtract 6 from both sides, and we get y is equal to 6. So that's your answer, 3, 6. Okay, that's where they cross. All right, so how do we know when to use what? So you would use graphing if you need to have a picture. It's not as common. Substitution would be when one equation is always already solved or can be easily solved for one variable. But the go-to usually is elimination. People use that the most. All right, so that's it for this section. Good luck, happy studying, and I will see you on the next video.